this part right now might be a little bit of information overload, and I know it just feel like you're drinking out of a fire hydrant as we're progressing through this section. So feel free, don't rush through it. Take your time, explore the helps that you have available to you. Watch these videos over and over again because I know you guys can get it, but you're not going to get it the very first time. It is going to take some effort and just processing the information as we go through it. So I apologize up front on this one because, again, I feel like I'm dumping a whole bunch of information on you, but I really do want you to get it, and I know that you guys can understand it. So we're going to look at this idea of composite functions. And what a composite function basically was where you composite or you combine its function and its inverse to get its original value. So for example, if I took a function and composite it with its inverse, I would get, in this case, x. And if I did it the other way around, where I took the inverse of the function, composite it with its function, and I would get x as well. And so that's what the composite function does that we're looking at. So how do we deal with that, dealing with trigonometric functions? And so what I've listed over here, you can find these in your textbook or you can Google it or whatever you may need to do, is I've looked at this composite idea of sines, cosines, and tangents. And so if I took the function, composited it with sine and its sine inverse, and I would get up x, you can see that pattern all the way through. However, here's the tricky part. Tricky part is we have to understand what its domain is. Where we can have its domain defined. And how we determine that is by what's on this inside part as well. So if this part right here on this very first one has a defined domain, that we know is composite function will have a defined domain. So we have to remember is, what was the domain of my inverse sine? And you have to flip back a couple of pages in her book, or remember that its domain was from -1 to 1. The second one here, we just look at the inner part of the function. And so this entire composite will be defined if on the range that the sine of x was defined. And we restricted that domain from -π12 to π12. Then likewise, you can look all the way down for the cosines and the tangents as well. I could read them out to you, or you can go back and refer to them on what we're doing. The take home though is we do need to be aware if the domain is defined. And it's defined for the entire composite if it's defined for that intersection. So let me show you a couple of examples and maybe kind of help clear this up a little bit. Here I want to find the value of the composite function where I take the inverse of sine of the sine of π4. Well, the first question I have to ask is π4, is that within the restricted domain? So if I go back and look over at my table where it follows this pattern right here, this was true on the domain from -π12 to π12. And π4 is indeed within that restricted domain. So therefore, I can say that the exact value, this value is out to π4. Another example, let's take the composite function where I take the inverse sine of the sine of 5/4 pi. First question I ask is sine of 5/4 pi, is that within its restricted domain? Well, the domain was again restricted to -π12 to π12, and I find out that 5/4 pi is outside of that restricted domain. So right now I can't do anything unless I start to remember some of the previous things we learned a little bit about, and I can find out, well, is there something else within that restricted domain that I could use that's equivalent to the sine of 5/4 pi? And 5/4 pi, that's in the third quadrant. So this would also equal to, whereas negative of the sine of π4. Both of those have the same sign value, and there I have π4, that is within its restricted domain. So if I remembered that both of these two things were the same, then I could use that to help me progress throughout this problem a little bit. So now the question is I want to find out what the value of minus a sine of π4 were. What was that value? And that value is √2 over 2. So and it's a negative right there because it was in the third quadrant, so all my signs are negative in the third quadrant. So the sine of pi over fourths was root 2 over 2. Since it's in the third quadrant, I need to bring this negative along. So all three of these are equivalent or produce equivalent sign. But this one now has the correct, the correct value and the correct domain that I can use with. So the inverse sine of root 2 over 2, again, whose angle produces a root 2 over a 2? And if I remember that, that was a negative pi fourths. So I can see that the composite function of the inverse of sine of the sine of 5/4 pi produces a negative pi fourths, and which is the value that I have in here. So those are some ways that I can kind of get a sense and use this property of composite functions. I know you're gonna have to watch this one again. I get it. So watch it again, and I hope that the second time it's more clear than the first time.